Hey everyone, I wanted to talk about a technique called vacuum frying today. So traditionally deep fat frying is a technique where we put the food into hot oil and remove some of the water from the food, at the same time replacing a portion of it with the hot oil. And while this is all going on, the heat from the oil also cooks the food. So we have both a cooking and sort of another alteration going on with the food. However, if you ever wanted to fry something like a fruit or a vegetable, the problem is that there's a lot of water in that item, and at a temperature high enough to cause the water to boil away, the outside would become scorched and the inside would still be too moist. So the vacuum frying technique allows us to change the boiling point of water by lowering the pressure in the pot. Just like high altitude cooking, you have to adjust the cooking time to compensate for the atmosphere. So here's 3 batches of fried bananas that I just made. And this is the vacuum fried bananas, the bananas fried at normal atmospheric pressure, and then also bananas fried under higher pressure. So with the same setup that I just built, I can also fry things under pressure, and that technique is actually used in fast food restaurants for fried chicken, and I'll talk about the reasons why in a minute. So the vacuum fried bananas are fairly stiff. They have a nice crispy outside, and if we cut one in half, it's actually fairly firm all throughout, although the inside is moist. However, the normal fried bananas have a very, very thin skin on the outside and are actually fairly soft throughout. And the pressure fried bananas are extremely crisp on the outside, but are also surprisingly soft on the inside. So the vacuum fried bananas were cooked at a lower temperature than the atmospheric fried bananas, and that was also still a lower temperature than the pressure fried bananas. So you might be saying, well, it's not surprising that this is more cooked, almost burned up here, because the temperature was higher. However, that is the point of this whole process. The vacuum frying allows us to do this oil-water exchange at a lower temperature, so we don't actually have to cook the fruit. We can keep it from losing all of its flavor. I mean, it has an uncooked flavor to it, and we don't have to brown it. We don't have to cook it like that. So the vacuum fried bananas have a really nice crunch to them. This is by far my favorite out of the 3. The normal fried bananas are a little soft, a little squishy, and these have a nice crispy outside, but the taste is kind of burned. I mean, it does taste a bit like charcoal, so that's kind of too much. So here's how I did it. I started with a commercial stainless steel pressure cooker that I bought at Bed Bath & Beyond today. I removed the handle from the lid and all of the safety features, and noticed that it had 2 holes already drilled for the pressure relief valve and like the normal relief valve. I loosely screwed in a couple of 1/8-inch brass pipe fittings and then silver soldered them on the other side. I connected the chamber up to my vacuum pump and pumped it down, and then realized I had a problem. The seal that comes with this pressure cooker is meant to be inflated by the pressure. So if you try to pull a vacuum inside a pot like this, the seal actually pulls itself in and it breaks the seal. So I took a piece of stainless steel welding rod and sort of bent it into a circle, and under spring pressure basically put it inside the seal so that it would hold the seal out to the outside. And this actually worked just fine for a while. After a couple of runs, there was enough oil kind of around the lid area that the seal was still slippery enough to pull itself in when vacuum was applied. So if I were going to keep using this setup, I would have to come up with basically a stronger ring, maybe a continuous ring, so that it won't collapse in on itself. I added a cold trap to the system, which is basically a thermos filled with denatured alcohol and dry ice. And the idea here is that all of the water that we're going to pull out of those bananas is going to end up in the cold trap instead of in my vacuum pump. So I talked about how to make this in an earlier video, in fact in my astronaut ice cream video. And the amount of water is fairly substantial, so if all of that water went into the vacuum pump, it would rust up, and if it was enough water, it might actually lock the pump up. I'm using an induction cooktop, which I'll probably take apart in another video to see how it works. It has a precision temperature control on the front so that I can dial in the temperature that I want the pot to be, and that's actually very close to the temperature that the oil is in the pot. I'm kind of curious how it knows the exact temperature. It might be doing a trick with the actual magnetics to determine the temperature of the steel. However, I think it's also likely that there's a temperature sensor just in the base, either IR or just contact. For the vacuum frying, I got the oil up to about 110 degrees C, and then loaded the banana slices in the pot and put the lid on and pulled a vacuum as well as the vacuum pump could manage. So I think in the literature there's sometimes specify a very low pressure that's above what a vacuum pump can make, so there's some regulation going on. But in my case I just did as much vacuum as the pump could handle. I cooked the bananas for about 12 minutes and then opened the pot up and took them out. The atmospheric cooking was pretty standard. I raised the oil temperature to about 170 degrees C and cooked them for a little under 10 minutes. So I know I'm varying the cooking time as well, but the surface had become so scorched that I realized that it was not going to be a desirable thing if it really cooked that much. For the pressure cooking, I changed one of the fittings on the lid and then raised the oil temperature to about 230 degrees C. And the idea with the temperature changes is to match the vapor pressure of the water in the food. So with the additional pressure in the chamber, I want the water to have just about the same propensity to leave the food. So that temperature change corresponds to the pressure change. In theory, this means that the food would be equally dried, since the water has just as much for a reason to leave the food with these different conditions. However, the higher temperature means that more cooking process will happen, and that's exactly what we can see here. I used my compressed air nozzle to add some pressure to the chamber and tried to keep it at just over 1 atmosphere. Of course, taking the food out is more difficult with the pressure case, because as soon as we lower the pressure, all of the food starts boiling extremely vigorously because it's been ramped up to this very high temperature and has been sort of stabilized at a higher temperature and pressure. This whole system is potentially practical for home use. I don't think we really need the dry ice for the cold trap. Since the pressures are a bit higher, I think we could get away with a less good vacuum pump and a less good cold trap and still get some pretty good results. Okay, see you next time. Bye.